In this video, we are going to be looking at the inverse of a product in a group. And so to get started, we are going to let G under star be a group. And we're going to let A and B be any elements of G. And my question is, what is AB inverse? In other words, we're going to multiply A and B together, and then I want the inverse. And when I say what is this, I'm looking for a formula that might not involve putting parentheses around elements and then putting the negative one outside. So I want to consider this problem in the following way. I'm looking for some element that I can multiply on the right side by AB and get the group identity. That's our goal. And I want to remind you that we've got all those nice 5 lemmas working for us. And one of the lemmas says that inverse elements are unique. So if I can find anything in here that works, it will have to be AB inverse. So look at this idea. If I've got AB sitting there, and yes, technically I've got parentheses, I can think about multiplying by a B inverse, and that's going to get rid of the B, and then I can multiply by an A inverse, and that should get rid of the A. So what I want to do is I want to look at this particular product. So it's the product of AB times the product of B inverse times A inverse. Now, the first thing that I'm going to do is I'm going to reassociate. In other words, I'm going to put the parentheses in a different place. So I'm going to write this as A times B inverse times A inverse. And I can do this by the associative axiom. Of course, what's sitting in here is a nice big fat E. And I know that by the definition of B inverse. Inverses are two-sided, not that it matters here, but B times B inverse is known to be the group identity. And of course, if I reassociate this way, I know that A times E is just A, so I'm now looking at A times A inverse. And that step is by the definition of the group identity element. Of course, what is A times A inverse? That's just E again, and that's again by the definition of A inverse. And so what we now have is we have the following fact. We now know that B inverse times A inverse is a right inverse for the element A times B, since, let me get my notation right, since AB times B inverse times A inverse turned out to be E. And we also know that right inverses are unique. Hence, the formal name for the inverse of AB is AB inverse, and it must be equal to B inverse times A inverse by the uniqueness of inverse elements. And that ends our proof.